Welcome, future data explorers. We live in a world that is absolutely swimming in data. Every time you stream a movie, buy a coffee, or even just walk down the street with your phone, you are creating tiny bits of information. Companies, scientists, and governments collect this information, but on its own, it's just a jumble of numbers and text. It's like having a giant library where all the books are piled on the floor in no particular order. This is where the data analyst comes in. You are the librarian, the detective, and the storyteller all rolled into one. Your job is to step into that messy library, find the important books, and tell everyone what wonderful stories they contain. So, what does a data analyst actually do? Imagine a company like Netflix. They have data on what you watch, when you watch it, what you stop watching, and what you binge watch in a single weekend. A data analyst at Netflix would look at all this information to answer important questions. Questions like, what kind of shows should we make next? Or why are people in Germany suddenly obsessed with a baking show from the 90s? By answering these questions, data analysts help businesses make smarter decisions. They don't just guess. They use evidence found in the data to guide the way forward, making them incredibly valuable in today's world. The demand for data analysts is booming, and for a good reason. We've moved from an age of intuition to an age of information. Businesses that use data to their advantage are the ones that succeed. They can understand their customers better, make their products more efficient, and even predict future trends. Think about it. A hospital can use data to predict when the next flu season will peak, and a city can use traffic data to make your daily commute shorter. The work of a data analyst has a real, tangible impact on the world around us. It's a career that is not only in high demand, but also deeply rewarding and intellectually stimulating. This guide is your roadmap. It's designed to take you from a curious beginner to a confident data analyst, ready for 2025. We will walk through the essential skills you need, step by step. We'll cover everything from the basics of spreadsheets to the power of programming languages and the art of making beautiful charts. We will look at where to find data, how to clean it up, and how to build a portfolio that will get you noticed. It might seem like a lot, but every expert was once a beginner. The journey is a marathon, not a sprint, and every single step you take is a step toward a fantastic new career. So, let's get started. Every great adventure needs a map, and your journey into data analysis is no different. It's easy to feel lost with so many skills to learn and tools to master. Where do you even begin? Thankfully, the internet has provided us with an amazing resource called roadmap.sh. Think of it as a community-created treasure map for various tech careers, including data analysis. It lays out a visual path, showing you the recommended steps and technologies to learn, from the absolute fundamentals to the advanced skills that will make you stand out. This isn't just one person's opinion. It's a collective guide built by experienced professionals in the field. Using roadmap.sh is incredibly simple and empowering. When you visit the site, you'll find different roadmaps for roles like front-end developer, DevOps, and most importantly for us, data analyst. Clicking on the Data Analyst Roadmap will reveal a large branching chart. The path starts with the basics and then splits into different areas of expertise. Each box on the chart represents a concept or a tool you should learn. The lines connecting the boxes show you the logical order. For example, it will show you that learning the fundamentals of a programming language should come before you dive into specific data science libraries. This visual structure helps you see the big picture and understand how different skills connect. The beauty of roadmap.sh is that it provides structure without being overly rigid. It highlights what is essential, usually marked with a specific color or symbol, and what is a good alternative or optional skill. For instance, in the programming section, it will likely present both Python and R as valid choices, allowing you to pick the one that best suits your interests or the jobs you're targeting. This flexibility is crucial because the world of data is always changing. The map is updated by the community to reflect the latest trends and most in-demand technologies, so you can be confident that you are learning what is relevant right now in 2025. So your first step is to go to roadmap.sh and spend some time exploring the data analyst path. Don't try to learn everything at once. Just look at the journey ahead. See the milestones, the foundational skills, the core technologies, the advanced topics. Use it to plan your learning. Maybe you decide to spend the first month on Spreadsheets and SQL, the next 2 on Python, and so on. This map will be your constant companion, a source of guidance and motivation. It turns the overwhelming task of becoming a data analyst into a series of manageable, achievable steps. Your adventure has a map. Now, let's pack your bag with the first tool. Before we dive into complex code and fancy algorithms, we must start with the most fundamental tool in the data world, the spreadsheet. Programs like Microsoft Excel or Google Sheets are the Swiss Army knives of data analysis. They are everywhere, used by everyone from small business owners to executives at massive corporations. Why? Because they are incredibly versatile and accessible. They allow you to organize data into neat rows and columns, perform calculations, and create simple charts without writing a single line of code. Mastering spreadsheets is not just a beginner step, it's a skill you will use throughout your entire career. It's the foundation upon which everything else is built. Your first task is to get comfortable with the basic functions. Think of these functions as spells that make the spreadsheet do your bidding. You start with simple arithmetic. Instead of manually adding a column of numbers, you can use the sum function. For example, equals sum open parenthesis, a 2 colon. A100 close parenthesis will instantly add up all the numbers in cells. A2 through A100 need to find the average sales for the month, the equals. Average function is your friend. Want to know the highest and lowest values? Use equals max and equals min. These simple commands are the building blocks for more complex analysis and will save you an enormous amount of time and effort. Once you have mastered the basics, you can move on to more powerful features like pivot tables. A pivot table is one of Excel's most magical features. It allows you to take a massive, intimidating table of data and quickly summarize it in a meaningful way. Imagine you have a list of 10,000 sales records with columns for product, region, and sale amount. With a few clicks, a pivot table can tell you the total sales for each product, broken down by region. It's an interactive way to slice and dice your data, look at it from different angles, and uncover patterns that would be impossible to see in the raw data. Beyond pivot tables, you should also learn about lookup functions like VLOOKUP or the more modern XLOOKUP. These formulas are lifesavers when you need to combine data from different tables. For example, you might have one table with employee IDs and sales figures, and another table with employee IDs and their names. VLOOKUP can pull the employee names into your sales table so you don't have to match them manually. Learning these functions will elevate your spreadsheet skills from basic data entry to genuine data analysis. Platforms like Coursera, Udemy, and even YouTube have excellent free tutorials to get you started on your Excel journey. If spreadsheets are the Swiss Army knife, then SQL is the powerful engine that runs the entire data warehouse. SQL, which stands for Structured Query Language, is the universal language used to communicate with databases. Almost every company stores its valuable data in databases, and SQL is the key that unlocks it. As a data analyst, you will use SQL every single day. It allows you to ask very specific questions and get precise answers back from massive datasets. You can select specific pieces of information, filter it based on certain conditions, and join different tables together to create a complete picture. Learning SQL is not optional, it is absolutely essential. The good news is that SQL is relatively easy to learn because it reads a bit like English. The most fundamental command is select. This is how you tell the database what information you want. For example, if you have a table called customers, you could write select name, city from customers to get a list of all your customers' names and the cities they live in. It's that straightforward. You are literally selecting the columns you want from the table you specify. This is the starting point for every query you will ever write, and mastering it is the first step toward becoming fluent in the language of data. Of course, you usually don't want all the data. You want to filter it. That's where the where clause comes in. It lets you specify conditions. Building on our previous example, you could write select name, city from customers, where city equals New York, to get a list of customers who live only in New York. You can also use other operators like greater than, less than, and equals to work with numbers. For instance, where sales greater than 1,000 would give you only the sales that were over $1,000. By combining select and where, you can already start to perform some powerful targeted analysis on your data. The true power of SQL, however, comes from its ability to work with multiple tables at once using joins. Most databases are relational, meaning the data is split into many tables that are linked together. You might have one table for customers and another for their orders. A join lets you combine them. For example, select customers.name, orders.product from customers. Join orders on customers.customer_ID equals orders.customer_ID would give you a list of which customer ordered which product. Learning different types of joins like inner join and left join is crucial. Websites like Khan Academy, Code Academy, and SchoolZoo offer fantastic interactive tutorials to practice these core concepts. While Excel and SQL are the bedrock of data analysis, programming languages like Python and R give you superpowers. They allow you to automate repetitive tasks, perform incredibly complex statistical analyses, and create sophisticated data visualizations and machine learning models that are simply beyond the reach of spreadsheets. For a modern data analyst, knowing at least one of these languages is becoming a standard requirement. They open up a whole new world of possibilities and allow you to handle data at a scale and complexity that would otherwise be impossible. The choice between Python and R often comes down to personal preference or industry demand. Python has become the undisputed king of data science and analysis, and for good reason. It's a general-purpose language, which means you can use it for many things beyond just data, like building websites or automating your computer. Its syntax is known for being clean and easy to read, making it a great first language for beginners. For data analysis, Python's power comes from its amazing ecosystem of libraries. Libraries are pre-written bundles of code that make complex tasks easy. The most important ones for a data analyst are pandas for data manipulation. Think of it as Excel on steroids, NumPy for numerical operations, and Matplotlib and Seaborn for data visualization. On the other side, we have RR was built from the ground up by statisticians for statisticians. If your work involves heavy statistical modeling or academic research, R is an exceptional choice. Its core strength lies in its vast repository of packages designed specifically for statistical analysis and data visualization. The Tidyverse, a collection of R packages including ggplot2 for visualization and dplyr for data manipulation, has become a standard for modern data analysis in R. It provides a consistent and intuitive grammar for handling data. While Python is more of a multi-purpose tool, R is a specialized instrument finely tuned for the art of data exploration and statistical inquiry. So, which one should you choose? The honest answer is that you can't go wrong with either. A good strategy for a beginner in 2025 is to start with Python. Its versatility and massive community support make it a slightly more practical choice for a wider range of jobs. You can learn the fundamentals on platforms like FreeCodeCamp or DataCamp. Once you are comfortable with Python and its data ecosystem, you can always pick up R later if a specific job or project requires it. The key is to choose one, stick with it, and learn it well. Your programming superpower awaits. Here's a secret of the data world. Most of a data analyst's time is not spent making beautiful charts or profound discoveries. It's spent cleaning the data. Real-world data is messy. It's kind of like trying to cook a gourmet meal with ingredients that are dirty, mislabeled, and sometimes just missing. Data collection and cleaning is the process of gathering this raw data and transforming it into a clean, reliable, and usable format. This step, often called data wrangling or data munging, is arguably the most critical part of the entire analysis process. Because honestly, if you start with bad data, you will end up with bad conclusions. Garbage in, garbage out. Data can come from a huge variety of sources. You might be querying a company's SQL database, downloading a CSV file from a government website, or using an API, application programming interface, to pull data from a social media platform like Twitter. The first step is simply getting the data into your analysis tool, whether that's Excel, Python, or R. Once it's loaded, the real work begins. You'll immediately start to notice problems. There might be missing values, represented as blanks or NA. There could be typos in categorical data, like New York being spelled as New York, and New York. Dates might be in inconsistent formats. Dealing with these issues is both an art and a science. For missing values, you have several options. You could delete the entire row, but you risk losing valuable information. Alternatively, you could impute the missing value, which means making an educated guess. For a missing age, you might fill it in with the average age of all other people in the dataset. For typos, you need to standardize your categories. This means converting NY and New York all into the single, consistent format of New York. This process requires careful attention to detail and a good understanding of your dataset. This is where your programming skills in Python or R really shine. Libraries like pandas in Python make these cleaning tasks much more manageable. You can write code to automatically find all the missing values and fill them with the mean. You can write a script to find all the different spellings of a city and standardize them with a single command. This is far more efficient and less error-prone than trying to fix thousands of rows by hand in a spreadsheet. Mastering data cleaning is what separates a novice from a professional analyst. It's the unglamorous but essential work that makes all the exciting discoveries possible. Once your data is clean and organized, it's time for the fun part, making it talk. Data visualization is the art and science of representing information graphically. A good chart or graph can reveal patterns, trends, and outliers that you would never see in a spreadsheet full of numbers. It's a form of storytelling. You are taking your findings and presenting them in a way that is intuitive, engaging, and easy for anyone to understand, even people who aren't data experts. A single, well-designed visual can be more powerful than a 1,000-word report. It's the bridge between your technical analysis and actionable business insights. To be an effective storyteller, you need to know which type of chart to use for which type of data. The most common and useful chart is the simple bar chart. It's perfect for comparing quantities across different categories, like sales figures for different products. If you want to show how something changes over time, a line chart is your best friend. Think of tracking a stock price or website traffic over a year. For showing how a whole is divided into parts, a pie chart can work, but be careful. They become hard to read with more than a few slices. A scatter plot is excellent for showing the relationship between two numerical variables, like a person's height and weight. As you advance, you'll learn about more sophisticated visualization types. A histogram looks like a bar chart, but it shows the distribution of a single numerical variable, helping you understand how your data is spread out. A heat map uses color to represent values in a matrix, which is great for visualizing correlations between many variables at once. The key is to always choose the chart that tells your story most clearly and honestly. Don't just pick a chart because it looks cool. Pick it because it best answers the question you are trying to ask of your data. Simplicity is often your most powerful tool. To create these visualizations, you have a wealth of tools at your disposal. You can start with the built-in charting features in Excel or Google Sheets for quick and simple plots. For more control and beauty, you can use Python libraries like matplotlib and Seaborn, or R's ggplot2. For creating interactive professional-grade dashboards, you'll want to learn dedicated business intelligence tools like Tableau or Power BI. These tools are the industry standard and allow you to build stunning, clickable dashboards that let users explore the data for themselves. Learning one of these BI tools is a must-have skill for any aspiring data analyst in 2025. If data analysis is about finding stories in data, then statistics and probability are the grammar of that storytelling. You don't need to be a PhD-level statistician, but a solid grasp of the fundamental concepts is absolutely essential. Statistics provides the methods to describe your data, make inferences, and quantify uncertainty. It helps you move beyond simply saying this number is bigger than that number to making confident statements like we are 95% certain that our new marketing campaign increased sales by at least 10%. It's the foundation of rigor that turns your analysis from guesswork into science. You should start with descriptive statistics. These are the tools you use to summarize and describe the main features of a dataset. You've already met some of these: mean, the average, median, the middle value, and mode, the most frequent value. These are called measures of central tendency. You also need to understand measures of spread or dispersion, like the standard deviation, which tells you how much your data points tend to deviate from the average. Is your data tightly clustered around the mean, or is it spread out all over the place? Understanding this is key to understanding the nature of your data. Next comes the world of probability. Probability is the language of uncertainty. As an analyst, you often work with samples of data, not the entire population. Probability helps you understand how likely it is that the patterns you see in your sample are true for the whole population. Key concepts to learn include understanding probability distributions, like the normal distribution or bell curve, and the difference between correlation and causation. Just because two things happen at the same time, which is correlation, doesn't mean one caused the other, which is causation. This is one of the most important lessons a data analyst can learn. Finally, you should have a basic understanding of inferential statistics, particularly hypothesis testing and A/B testing. Hypothesis testing is a formal procedure for checking whether your findings are statistically significant or if they could have just happened by chance. A/B testing is a practical application of this, used constantly in the tech industry. For example, a website might show half its visitors a blue Buy Now button, version A, and the other half a green one, version B. By analyzing the results, a data analyst can determine with statistical confidence which button leads to more sales. Resources like Khan Academy and the Crash Course Statistics series on YouTube are excellent places to learn these essential concepts in an accessible way. Once you have a firm grasp of the fundamentals, Excel, SQL, a programming language, visualization, and statistics, you can start looking toward the horizon. The fields of machine learning and big data are the natural next steps on your data journey. Machine learning, or ML, is a subset of artificial intelligence where you teach computers to learn patterns from data without being explicitly programmed. Instead of writing rules, you feed the computer an algorithm and a lot of data, and it figures out the rules on its own. For a data analyst, ML can be a powerful tool for making predictions. There are a few main types of machine learning tasks you should be aware of. The first is supervised learning, where you have labeled data. This includes regression tasks, where you predict a continuous value, like predicting the price of a house based on its features, and classification tasks, where you predict a category, like classifying an email as spam or not spam. The second type is unsupervised learning, where your data is not labeled. Here, the goal is to find hidden structures, such as clustering customers into different market segments based on their purchasing behavior. Python's scikit-learn library makes it surprisingly easy to start experimenting with these models. Then there is the concept of big data. This term refers to datasets that are so large and complex that traditional data processing application software is inadequate to deal with them. We're talking about petabytes of information generated by social media, sensors, and global transactions. As an analyst, you may not need to build big data systems, but you should understand the basic concepts and why they matter. Technologies like Hadoop and Spark were developed to store and process these massive datasets across clusters of computers. Knowing what they are and what they do will make you a more well-rounded and valuable analyst. The journey of a data analyst is one of continuous learning. The tools and techniques are always evolving. To stay current, you must be proactive. Follow data science blogs, listen to podcasts, and join online communities on platforms like LinkedIn, Reddit, like the R Data Analysis subreddit, or Kaggle. Networking with other professionals is invaluable. A great way to solidify your skills and showcase them to potential employers is by building a portfolio of projects. Find a dataset you're passionate about, sports stats, movie ratings, climate data, and analyze it from start to finish. Document your process, from cleaning to visualization to your final insights, on a platform like GitHub or a personal blog. Your portfolio is proof that you can do the work. Don't wait for permission. Start small, learn consistently, and build your future one dataset at a time. The adventure is just beginning.